All right, Brianna, can you read this for us today? By the way, we're going to talk about similar polygons, okay? So, Brianna, go ahead. Can you read this for us right here? Okay, everybody listen now.
When you draw a diagram of a soccer field, you don't need an enormous piece of paper. You use a convenient sheet and draw the scale. You show the right shape, but in a convenient size. Two figures such as those below that have the same shape are called similar.
So here, you see, these are similar figures. Now, of course, when you draw a soccer field, you don't want to draw 1-to-1 ratio. You know what I mean? It's too big. So, you know, when you draw maps and so forth, right? You draw to scale. So we're going to talk about then similar polygons. Same sort of idea. Okay, so let me give you the definition of what we mean by similar polygons. But I'm sure a lot of you have sort of an idea in your head as to what we mean by this. Okay, so hold on. Here we go. Here's the definition of similar polygon. Two polygons are similar if their vertices can be paired so that, first, there are two parts for this. First, what can you tell me about their angles? Anybody want to tell me? Yes?
They're congruent.
Yeah, the corresponding angles are congruent. But what about the corresponding size? Are they going to be congruent also? No, then it'll be 1-to-1. Anybody want to guess? Yeah.
They have the same ratio.
Exactly right. So secondly, the corresponding sides are in proportion. Okay. In other words, their length have the same ratio, as you said. So these two things must be true in order for two polygons to be similar. Okay. So there's a definition. So go ahead and write it down, and I'll wait. And this is what we expect it to be. Isn't that right? Okay. Can somebody read this for us here? When you refer to, so here's an example of similar polygon. Go ahead.
When you refer to similar polygons, their corresponding vertices must be listed in the same order. With polygon PQRST similar to polygon VWXYZ, you write polygon PQRST polygon VWXYZ.
Oh, what does that symbol you think means? Yeah, similar. Okay, so you read it as polygon PQRST similar to polygon VWXYZ. Okay. Look at that symbol. Doesn't that symbol looks kind of similar to the congruent symbol? Except with the equal sign. And you see why it's not equal now? Because corresponding sides are not what? Equal, congruent anymore, right? So we use that symbol. Does that make sense? And notice it's kind of similar in a way that they write, right? They have to write these in order, right? With the corresponding vertices. Just like when you had the congruent polygons. You guys remember that?
Did you write this?
No, you don't have to write this. Does that make sense? Yes? You guys have? Okay, so if they say PQRST, guess what? The corresponding vertices are what? PN, V, QN, WRN, XSN, TN. Does that make sense? That's how that works. Okay, so as you can see from the definition here, exactly what you said, right? All these are these are the corresponding angles, right? They're congruent. What can you tell me about the corresponding size? They're in right. They're in the same proportion, right? Same. So they're in the same ratio. So PT to what? VZ, TS to ZY. By the way, what is the ratio of these corresponding size? 8-to-5, isn't it? It's 20-to-32, which is 8-to-5. So now, do you see how these corresponding sides are going to be in proportion like this, right? And all these, the ratios will be the ratios for all these corresponding sides will be 3-to-5. Should we say 8-to-5 or 3-to? Should we say 5-to-3 or the other way around? 5-to-8 or 8-to-5?
5-to-8.
Why 5-to-8, not 8-to-5? You're right. You should say these.
It's in order.
Yeah, which order?
The thing you say first.
Yeah. So we're talking about the smaller polygon first, and then the bigger one, right? Does that make sense? Do you always have to start with the smaller polygon? No. It depends on what they give you, right? They told us that these two are similar. The smaller one first, and then the larger one. So there's a name for the ratio of the corresponding size. Anybody want to guess what that name is? Yeah.
Quotient.
No. It's called scale factor. So Austin, can you read this for us? Similarity.
has some of the same properties as equality and congruence. Similarity is reflexive, symmetric, and transitive.
Oh, okay, sorry. So we should talk about that first. So similarity has some of the same property as the equality and congruence. So guess what? You could have reflexive property of similarity, symmetric property of similarity, and transitive property of similarity. Okay. Just like just like the congruence. Didn't we have reflexive property of congruence, symmetric property of congruence, and transitive property of congruence, and so forth? We also had reflexive property of what? Equality, symmetric property of equality, and transitive property of equality. You guys remember that? So guess what? It also works for similarity. Okay, does that make sense? So this property will also work for similarity. All right. Okay, so go ahead and write that down. I'll wait. Okay, then, as I said before, so then write this down. If two polygons are similar, then the ratio of the length of two corresponding sides is called the scale factor. Okay, so as we mentioned before, the scale factor of the example that we had up there was 5 to 8. Does that make sense? Yes?
Yes.
Okay, go ahead and write this down. I'll wait. So, okay, somebody read this for us now. Let's move on to some examples. Yes, go ahead, Nicole.
The example that follows shows one convenient way to label corresponding vertices A and
A prime.
A and A prime,
Hmm?
and B and B prime, and so on.
Yes. So what do you think? Okay, look, notice you have two quadrilaterals, right? One of them is A, B, C, D. The other is what? A prime, B prime, C prime, D prime. Why do you think they say it's a convenient way to label these corresponding vertices? Hint, to label the corresponding vertices. Why do you think? Yes, Samantha?
It's really easy to know that A is corresponding to A.
Exactly. A, it's really easy to see that A is corresponding to A prime, right? Rather than using some other variable. Does that make sense? So you will see that on these similar polygons, they do that a lot, okay? So you could see, guess what? B is corresponding to B prime. What about C? B prime. What about D? Isn't that easy? Okay. So that's how they label these things. Any question? All right, go ahead and try then this example. Find their scale factor, the values of x, y, z, the perimeter of the two quadrilaterals, and the ratio of the perimeters. Go ahead, everybody try. I'll wait. Yeah, here you go. Andrew, can you tell me their scale factor?
2 to 3.
2 to 3. How'd you get that? You're right.
Oh, DC and DC.
Yeah, you compare DC to D prime, C prime. That's how you read it. Right? Because those are the corresponding what? Side. Okay, so it's 2 to 3. Now that we know the scale factor for these similar triangles, you know that any other corresponding sides would have the scale factor of what? 2 to 3. So we can figure out x. X to 21 is same as what? 2 to 3, right? Is it 3 to 2 or 2 to 3? Okay, because you're going smaller one to the bigger one, right? So what did you get as your x? How about Jason? 14. How many people got 14? Good. Okay. What about for... Okay, so you got x equal... For y, did you guys get 12?
Yes.
How many people got 15 for z? Easy enough?
Yes.
All right, then let's see. What can you tell me about the perimeter of these two? How about... Kristen, what did you get for the first?
A, B, C, D is 52.
52 is correct. What about for the A prime, B prime, C prime, D prime? Jet, what'd you get? 78 is correct. Now, what is then, let's answer D, the ratio of the perimeters. Yvetta, what's the ratio of the perimeters? 2 to 3, isn't that interesting?
Because all the sides are 2 to 3 anyway.
Oh, yeah, yes.
It's 2 to 3, isn't it? 52 to 78, right?
26.
Isn't that 2 to 3?
Yes, I got 2.
Right?
Isn't that the
I got
property?
23.
Guys, it turns out this is always going to be true. If the two polynomials are similar, okay? Listen. If the two polynomials are similar, guys, every time you have a perimeter of the one, right, compared to the perimeter of the other, it's going to be the scale factor. Always. Why is this true? Everybody discuss with your group, because think about what we did last time. Okay, who thinks they know why the ratio of the perimeter would always be the scale factor when the two polynomial polynomials. When the two polygons are similar. Okay, how about, who haven't I called today? I haven't called Josh. What do you think?
Property of proportion.
Okay, which one though? We had a whole bunch here.
The one when you like add number 2.
Yeah, number 2. You guys remember? Right? Remember we said that if two polygons are similar, look, corresponding sides are in?
2 to 3.
Yeah, 2 to 3, same proportion, right? So, look, like A over B is equal to C over D. You could think of those as what? The corresponding sides, right? And then when you add up all the numerators, that's same as adding up all the sides of one polygon. Whereas when you add up all the denominators, that's same as adding up all the sides of the other polygon, right? And we learn why it becomes A over B, right? Which is same as C over D and E over F, right? Does that make sense? So this is always going to be true. If two polygons are similar, right? You compare their perimeters, right? It'll be the same as the scale factor. Any question? All right, let's do one more example then. Here we go, guys. Try this one. Tell me ABC, A through H, if the quadrilateral ABCD is similar to quadrilateral EFGH. I should have done A prime, B prime, C prime. Oh well. Okay, go ahead. Everybody try. I'll wait. Okay. So, Young, what did you get for angle E?
Angle E, 60.
Correct. That's easy, right? Because angle A and angle E, they're the corresponding angles. So 60. Chris, what do you get for angle G? 90. Right. Nicholas, what did you get for angle B?
Angle B was. Oh, angle B. Sorry, I thought you meant letter B.
100 is correct. And by the way, if angle D is 110, what's H, class? Measurement 110. By the way, do they have to tell us it's 110?
Yeah.
Oh yeah.
Oh.
Because we know all the three other ones. Yeah, it should add up to
360.
360. Okay. What's the scale factor? How about Amy?
1 to 3.
1 to 3. How'd you get 1 to 3? You're right. Because it's 4 to 12, right? So it's 1 to 3. Correct? So since we know that the scale factor is 1 to 3, Eamon, how do you find EH?
The answer or how to find it?
And how do you find it?
You divide 21 by 3.
Don't you set up a proportion? 5 to EH as to what?
No, that's not.
So what's the proportion that you need to figure out what EH is? 3 to 1 as to what? 5 to EH, right? Do you know what I'm talking about? Yeah, so how did you get 15? That's what I'm asking. Don't you have to set up a proportion?
Yeah.
How do you set up a proportion, Eamon?
So you do like 5
Yeah, 5 over, let's call it x. Okay, 5 over x equals to what? 1/3, right? Let's call it EX as x, right? EH as x. So what's the answer? 15. Okay, same thing for BC. What's BC, Jonathan?
2.
2. How many people agree with Jonathan? Okay.
Divide 6 by 3.
Yeah, there are many ways to do it. But can we just set up a proportion and get it this way? So is the answer 2? Okay, what about AB? What's AB? How about, who haven't I, Bongwon, what do you think? 7 is correct. How many people got 7? Easy enough?
Yes.
Can you do something like this for your homework today?
Yes.
Good.